Hello everyone, welcome to the channel Code Like It. Guys, if you find this video helpful, please like this video and subscribe to the channel. Now let's see today's problem, largest BST. You are given a binary tree. Your task is to find the size of the largest subtree within the binary tree that also satisfy the properties of binary subtree BST. The size of a subtree is defined as the number of nodes it contains. A subtree of a binary tree is considered a BST if for every node in that subtree the left child is less than the node and the right child is greater than the node without any duplicate values in the subtree. So in this question we are given a binary tree and we need to find the largest BST. So BST is a tree, binary tree which have the left node less than the current node and the right node greater than the current node. So we need to, and the size of the BST is the number of node it contains. So our the problem is simple. So what we can do is we can maintain we can maintain a rest variable which will be which will have the size of the largest BST we have seen so far, and we will iterate we will recursively call for the left subtree and the right subtree. If we find the current tree is not a BST, then we are simply return some value so that we will not continue this subtree. Else we wanna find the size of the left subtree and the right subtree, and we will increment that size by 1. So let's look at the code for the more clear explanation. So we are initializing rest with 1 because at least one node is present in the tree, and we will call this solve function with root and this result variable. This solve function will return a vector which will contain 3 values. So the 3 values are, the first is the minimum value, the second is the maximum value, and third is the count of node in the subtree. So we require this minimum and maximum value because to check for every subtree we are using a post order traversal. We will evaluate left first, then right first, and then the root node. So after this left and the right call, we're gonna need some variable so that we can check if this root node is greater than the left node and less than the right subnode. So hence we are using these 3 variables. So if a node is a null pointer, so we will return these 3 zeros because we don't have any value. So we will call for the left subtree and we will call for the right subtree. If we find that we're gonna return -1 in that case when either our left subtree is if either our subtree is not a binary subtree, so we will return the -1 at the third place. So if left index 2 is -1 or the right index 2 is -1, then we are gonna simply return this value 0 0 -1 because we cannot form a BST here, so no need to evaluate this BST. We will check if the left of 2 is not equals to 0. It means that we don't have encounter any leaf node and encounter any null pointer. For example, the left of this one will be it will be a null pointer. That's what we are going to return 0. So for this case, for 2, the left is not a null pointer, so we will return 1. So if left is not equals to 0, then we will check if this the left node's maximum value is greater than or equal to the current node. It means that this one is greater than or equal to 2. If it is yes, it means it is not a BST. So we will simply return 0 0 -1. So this is a fixed template. If we don't find any BST, we will simply return 0 0 -1. Similarly, we will check for the right BST. If the minimum of right BST is less than or greater or equal to this node, it means this 3 is less than or equal to this the node's current value. We will simply return 0 0 -1 because it is not a valid subtree. Then now we are sure that the current BST after these checks, we are sure that our current BST of the current node we are standing at is a BST. So then we need to simply return the correct minimum, maximum, and then root nodes, the count of nodes for the right subtree plus the left subtree and 1 for the current node. So what we are going to do is to get the minimum and maximum. Sometimes it is possible that a tree is skewed. For example, if don't have any right right subtree. So in this case, we are simply initializing minimum with the nodes value and the maximum with the nodes value. If we don't have encounter any null pointer in the left tree traversal, then we're gonna just simply replace this minimum value with the left subtree's minimum, because for the current node the minimum will be left subtree's minimum. And for the cases where we are iterating over the leaf node, then in that case the minimum and the maximum will same with the root node, with the current node. So if right of 2 is not equals to 0, it means we have encountered a leaf node or any other node. Then we're gonna simply replace this maximum with the right stream maximum, which will be 3 here for this 2. So in the end, we gonna nodes count will be left subtree's children's count plus a right subtree children's count plus 1 for the current node. After that, the rest will be incremented, or we're gonna check if we're gonna take the maximum of res, current res, and the nodes count, and simply return this min, max, and nodes count. So and in the end we are simply return this res. So the time complexity will be big O of n, because we are traversing each node only once. Also, if we find any BST, any node currently node we are staring at is not a BST, we will simply return from that. So at least we are checking for the for every node. So time complexity will be big O of n, and we are not using any external space here. So guys, if you find this video helpful, please like this video and subscribe to the channel. Thank you.